NEC Table 310.15b6 is specifically designed for 120/240 volts, 3-wire single-phase dwelling services and feeders. The key is understanding that its application is limited to this specific voltage and wiring configuration. When dealing with different electrical systems, such as those found in apartment complexes, it's crucial to correctly identify the system type to ensure the appropriate code requirements are followed. In the context of an apartment complex with a 120/208 volts 3-phase service and individual 120/208 volts 3-wire single-phase metered services to each unit, Table 310.15b6 is not the applicable reference for determining minimum conductor sizes. The NEC, or National Electrical Code, provides various tables and guidelines for different scenarios, each tailored to specific voltage levels, wiring configurations, and load conditions. Table 310.15b6's purpose is to offer reduced conductor ampacity requirements for single-phase dwelling services and feeders under specific conditions. However, this allowance does not extend to 3-phase systems. For 120/208 volts, 3-phase services and feeders, the appropriate table to consult for minimum conductor sizes is Table 310.16. Table 310.16 provides ampacities for conductors insulated at 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius, with adjustments based on the ambient temperature and the number of current carrying conductors in a raceway or cable. To accurately size conductors for a 120/208 volts 3-phase system, you must follow the guidelines outlined in Table 310.16, considering factors such as the conductor's insulation type, the ambient temperature, the number of current carrying conductors, and any applicable correction or adjustment factors as detailed in NEC Article 310. It's also essential to consider other factors such as voltage drop, which may necessitate larger conductors than the minimum size required by Table 310.16 to ensure adequate voltage is maintained at the load. Voltage drop is the decrease in voltage that occurs along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause equipment to malfunction or operate inefficiently, therefore it is critical to consider voltage drop when sizing conductors, especially over longer distances. The NEC provides guidelines and formulas for calculating voltage drop to ensure it remains within acceptable limits. To correctly apply Table 310.16, you will need to determine the load served by the conductors. This involves calculating the total current the conductors will carry under normal operating conditions. For dwelling units, this calculation typically includes general lighting and receptacle loads, appliance loads, and any other permanently connected loads. The calculated load must be determined in accordance with NEC Article 220, which covers the calculation of branch circuit, feeder, and service loads in buildings. Once the calculated load is known, you can select the appropriate conductor size from Table 310.16 that has an ampacity equal to or greater than the calculated load. It's important to note that the ampacities listed in Table 310.16 are based on specific installation conditions. If the actual installation conditions differ from those assumed in the table, you may need to apply correction or adjustment factors to the ampacity values. For example, if the conductors are installed in an area with a high ambient temperature, you will need to apply a temperature correction factor to reduce the ampacity of the conductors. Similarly, if there are more than 3 current carrying conductors in a raceway or cable, you will need to apply an adjustment factor to account for the increased heat generated by the conductors. In summary, for a 120/208 volts 3-phase service in an apartment complex with individual 120/208 volts 3-wire single-phase metered services, Table 310.15b6 does not apply. Instead, refer to Table 310.16 and follow the guidelines in NEC Article 310 for determining the minimum conductor sizes, taking into account factors such as the conductor's insulation type, ambient temperature, number of current carrying conductors, and voltage drop. Understanding the specific application of each NEC table is crucial for ensuring safe and compliant electrical installations. Utilizing the incorrect table may result in undersized conductors, leading to overheating, insulation damage, and potentially fire hazards. Therefore, always refer to the appropriate table based on the voltage, wiring configuration, and load conditions of the electrical system being installed. Additionally, consult with a qualified electrical professional for any questions or clarifications regarding the application of the NEC. They can provide expert guidance and ensure that all electrical work is performed in accordance with the code. The NEC is a comprehensive document that requires a thorough understanding of its various articles and tables. It is essential to stay up to date with the latest edition of the NEC to ensure compliance with the most current safety standards. Regular training and education on the NEC are highly recommended for all electrical professionals. The NEC is not intended to be a substitute for proper engineering design, but it provides minimum requirements for safety. Therefore, it is important to consider other factors such as load growth and future expansion when designing an electrical system. Selecting conductors that are larger than the minimum size required by the NEC can provide additional capacity for future loads and improve the overall reliability of the system. This is especially important in apartment complexes, where the electrical demand may increase over time as tenants add more appliances and electronic devices. In addition to conductor sizing, the NEC also covers other important aspects of electrical installations such as overcurrent protection, grounding, and wiring methods. Overcurrent protection devices such as circuit breakers and fuses are designed to protect conductors from overheating due to excessive current flow. Grounding is essential for providing a safe path for fault current to return to the source, reducing the risk of electric shock. Wiring methods refer to the types of raceways, cables, and other materials used to install electrical conductors. The NEC specifies the acceptable wiring methods for different applications. For example, in apartment complexes, conductors are typically installed in metal conduit or cable trays to provide mechanical protection and prevent damage. The NEC also addresses the installation of electrical equipment such as panel boards, transformers, and generators. Panel boards are used to distribute electrical power to branch circuits throughout the building. Transformers are used to step down the voltage from the utility supply to the voltage required by the equipment. Generators are used to provide backup power in the event of a power outage. The NEC specifies the requirements for the location, installation, and wiring of these types of equipment. It is important to follow the NEC requirements for all electrical installations to ensure the safety of building occupants and prevent property damage. Failure to comply with the NEC can result in fines, penalties, and even legal liability. Therefore, it is essential to hire qualified electrical professionals who are knowledgeable about the NEC and have experience in performing electrical work in accordance with the code. Regular inspections and maintenance of electrical systems are also important for ensuring their continued safety and reliability. Electrical systems should be inspected periodically for any signs of damage, wear, or deterioration. Maintenance should be performed as needed to repair or replace any damaged or worn components. Proper maintenance can help prevent electrical failures and extend the life of the electrical system. In conclusion, understanding the specific requirements of the NEC is crucial for designing and installing safe and reliable electrical systems. When working on a 120/208 volts, three-phase service in an apartment complex, remember that Table 310.15b6 does not apply. Instead, refer to Table 310.16 and follow the guidelines in NEC Article 310 for determining the minimum conductor sizes. Always consult with a qualified electrical professional for any questions or clarifications regarding the application of the NEC. They can provide expert guidance and ensure that all electrical work is performed in accordance with the code. It is important to emphasize the significance of understanding the nuanced applicability of NEC tables, particularly in complex electrical systems like those found in multi-dwelling units. The NEC is a living document constantly evolving to address new technologies and safety concerns. Staying informed about these changes is paramount for any electrical professional. Furthermore, remember to document all electrical work performed, including conductor sizes, overcurrent protection ratings, and grounding methods. This documentation can be valuable for future maintenance and troubleshooting. The NEC also provides guidelines for labeling electrical equipment and circuits. Proper labeling can help prevent confusion and ensure that the correct circuits are de-energized during maintenance or repairs. In addition to the NEC, local codes and regulations may also apply to electrical installations. It is important to check with the local authorities to determine if there are any additional requirements that must be followed. The authority having jurisdiction, or OJ, is responsible for enforcing the NEC and other electrical codes. The AHA may be a local building inspector, a state electrical inspector, or another qualified individual. The AHA has the authority to approve or reject electrical installations based on their compliance with the code. It is important to work closely with the AHA to ensure that all electrical work is performed in accordance with the code and to obtain the necessary permits and inspections. Remember that electrical safety is everyone's responsibility. By following the NEC and other applicable codes and regulations, we can help prevent electrical accidents and protect lives and property. The NEC is a valuable resource for electrical professionals and anyone involved in the design, installation, or maintenance of electrical systems. By taking the time to understand the NEC, we can ensure that electrical work is performed safely and correctly, and always prioritize safety when working with electricity. To energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. Electricity can be dangerous if not handled properly. The NEC is designed to help us work safely with electricity and prevent accidents. So, let's all do our part to promote electrical safety and ensure that electrical installations are performed in accordance with the code. And that concludes our discussion on the applicability of NEC Table 310.15b6 and apartment complexes. Remember to always refer to the appropriate NEC table based on the specific voltage, wiring configuration, and load conditions of the electrical system you are working on. Stay safe and keep learning about the NEC.